And we're live. Okay. Hello all, hello world. This is day 124 of studying compilers every day until I land a compiler role. Last time we finished cleaning up some of this random move stuff and just figure out what we wanted to do with fees. This time we're gonna finally start trying to do something with fees. And what that requires is pretty much just this shenanigans. I'm not looking forward to implementing this. This seems rather annoying, but we'll figure it out as we go. Yeah. So something borked, and I had to restart my Tmux stuff, but it is what it is. So we need to split critical edges first, and then we need to figure out whatever the hell conventional SSA is. I remembered reading about that, but I kind of forgot what it actually is. So I guess we can what was it called? SSA. That's not what I want. It's SSA base underscore. There we go. Yeah, so we will just be staring at this a little bit once again. I think this was mentioned in the destruction at least. There's also a definition of conventional SSA here, which might be useful. Yeah, okay. Something webs. Let's just make this readable. Yeah, so we have webs. Which figure? 2.4? Oh, I guess that makes sense. Okay. Okay, so then let me zoom in a little more. Okay. Conventional SSA form is defined as an SSA form for which each fee web is interference free. I guess that makes sense. Copy propagation, transformed SSA, sure. 2.4C. Okay. So original code is that. Transformed SSA versus conventional. I guess that kind of makes sense. Okay. Okay, that makes sense. Each web can be replaced with a single variable. I guess that makes sense. All definitions and uses are renamed. Okay. SSA destruction starting from non-conventional SSA can be performed through a conversion and okay, sure. That, yeah. Okay. So, I guess that kind of makes sense. Yeah, I guess we can just look at the destruction algorithm and call it a day. Here it is. So this discovers fee webs. Okay, so we need to split critical edges. Okay, let's scroll up a little bit more. What is this texture reading? It is SSA based compiler design. It's like a big book of just like static single assignment related stuff in compiler design. Okay. Something like conventional. All fee related variables into unique representative variable. Sure. Union find our beloved. Okay. Do we need this? View of discovery algorithm. I guess we don't explicitly need it here, right? This just describes what a fee web is. Okay, this may not be the case if you're performing copy propagation. Yeah, okay. Split all critical edges. Not most efficient, I don't care. Yeah, okay, that makes sense. So we'd have to just like generate this in a little bit more of an awkward way, but that's fine. Critical edge is an edge from a node, several direct successors with several direct predecessors. I see. So it's many and many out, I guess. The process of splitting an edge, replacing from block 1 to block 2. Edge to... Okay, that... Sure. I guess that makes sense. A parallel copy. So few functions have a parallel semantic, so they have to be executed simultaneously. I guess that makes sense? I don't really get that yet. What is a parallel copy? Can be directly oh, that's interesting. Oh, that's quite neat actually. So we delete line 13 and then replace that with A0 and add remove. Oh, I guess that makes sense, sort of. Destruction things, drawbacks, okay. Permit splitting, okay. Theory of reducing frequencies with the rule of coalescing, yeah. So that's what we're gonna do. It's gonna be quite slow, but it'll work, which matters at the end of the day. Conservative coalescing, yeah, as opposed to aggressive, sure. Is there like a better diagram somewhere? I guess not. So I guess we could just implement this and then implement that. That's not what I want to do. Yeah, we can just implement the two of those, and I think we can call that a day. Okay. So once we have parallel does this... Okay, I see. So this... This just makes conventional SSA. And that makes parallel copies as well, right? Yeah, these are the parallel copies, I guess. And then after that, we sequentialize them. Okay. What is a parallel copy? I don't understand that very well. Let's look up SSA destruction. Yeah, okay. This might fall blind for a bit. Apologies. Okay. Dominator, sure. Yeah, we have that. We know that. Interesting. Oh, this is about construction. Wait, we got through that. Okay, so where do we destroy it? Ah, here we are. Okay. So replace fees with copies and direct predecessors. Yeah, that makes sense. So very simply here, can I just, yeah, okay. So we delete that and then we replace that with copies. That makes sense. That also makes sense. Yeah. So redundant assignments, so we insert empty blocks. Oh, I see. Yeah, okay, that makes sense. Hello copy and interpretation. Oh, I see. Yeah, that makes a lot of sense, yeah. So in this example here, I guess it wouldn't be this example, but I guess that makes sense, yeah. So I guess this is a parallel copy. I guess that makes sense because they are literally parallel as opposed to like this. Okay. Oh, what a great slide. Okay, great. So I guess that kind of makes sense now. I guess we can stare at the algorithms now, I guess. This might be a little bit uninteresting as I just like read this silently. So we get all the, I guess I could, yeah, sure. Yeah, so these are the incoming edges of the basic block. For each edge, so I guess for each predecessor, if it has several outgoing edges, then we split the edge, I guess. Is that the term? Split? Yeah, so we create a fresh empty block and then we insert the parallel copy there. Otherwise we just stick it on the end. That makes sense. For each fee at the okay, so for each fee, wait. Have you learned about the dominance frontier? Yes. I already have SSA construction done. Right now I'm working on the back end, and that does require destruction, which I have not learned about up to this point. So, yeah, that's my life now. So for each fee, oh, I see. Okay. Okay, I guess that makes sense. Is there a reason to not just do this, like, this direct destruction thing here? Like, it mentions a bunch of things here. Okay, let's... I swear there was like a thing for this. Oh wait, this is the... SSA destruction. I feel like there is like some slide deck somewhere. I guess that makes sense. Sequentialize. Oh. Matrix math. Okay. Okay, yeah. So surely we don't generate anything that we can't split, right? Or I guess there isn't an instance we can't go back to conventional SSA, right? Okay. So let's ChatGPT. I guess SSA, conventional SSA. This is not what I want. Is there anything interesting here? Sorry, let me just... There we go. Sure. Wow. Okay, we're just gonna do this, and then if/when it breaks, it will be really funny. That is how I will approach this. I have decided. So how do we do this? We could. How do we do this? How do we do copies? I don't think I have the notion of a copy. That's a problem. That is a problem. How does LLVM do this? Is there an instruction for this? Oh god. Okay, I'm happy to read this. I'm a lot less happy to read this actually, upon closer inspection. Maybe it's in here? I guess it just doesn't, presumably just doesn't exist in LLVM. Huh? Okay, we're just gonna throw this in ChatGPT now. Let's go cracks dev. Yeah, okay. This is annoying. Okay, so we will just have to just like throw this somewhere else. That's quite irritating actually. Huh? Yeah, okay. So that's not helpful for what I want. Hmm. I see. This was the whole parallel copy thing. That makes sense. Do I want to just like make a parallel copy instruction and call it a day? And then like we handle it later. Is this the play? I guess that's implied here. Or yeah, this thing. Okay. Sure. Okay. So where do we want to do this now is the second question. Do we want this as like a middle end pass? Because I feel like that kind of breaks some sort of... Or I guess like that couples in a weird way. Grr. Boss knot paper. Okay, we'll just copy this real quick. If I can copy correctly. Okay. Huzzah. Okay. Oh, it's our boy. Sure, okay. Enter the base, sure. Okay, I'm not particularly interested in the proofs right now. Okay. I mean, I could do this, or I could be lazy. Yeah, I'm quite skimming this. Huzzah, okay. Okay. Yeah, this is enjoyable to read. I guess that makes sense. I wonder if this is copied in the, or covered in here. They're like, is there like an advanced destruction? I guess not. Fair enough. Wow, there's so much stuff here. Anyway, I might just. Where do I even put this? It feels wrong to throw this into the middle end for like critical edge splitting, but I feel like that's kind of the only way to go about it. I mean, I guess we could just insert these empty blocks. And then the rest of this we could... No, that doesn't seem right. Her. We could just put this in destruction and call it a day. Or like in the back end. Does this have a parallel copy instruction at all? Or actually... How do we represent this here? We could probably just keep the fees. Right, and then we could mess with those in the back end. So I think we just have a pass that like splits critical edges. And then we worry about this stuff later. I'm not sure if that's like correct though. Oh, huzzah. Okay, so presumably that's a critical edge. Yeah, okay, that makes sense. Alright, this is interesting. Quite like this. Also, can we make this... Okay, that's much better actually. Is there anything interesting here that I don't know? No. Okay. That makes sense. Because modern processors do not implement phi functions. That's pretty funny. Yeah, that makes... yeah, this... yeah. Okay, so then... sure. Okay. Oh yeah, so there's a swap problem and lost copy. This was what I... this was one that I heard of before. Actually, no. I'll look that up later. Basic blocks will accept arguments. That would be... I should have done that. I should have just done basic block parameters. They're just what it is. There's no work about... sure. Oh, huzzah. Wait. It's a fallible operation. This is the paper that you mentioned. Okay, well that was a fun read at least. Okay, so I guess we can just split the edges and then we can figure out the whole parallel copies shenanigans later on. So for now, I guess we can change this to like split critical edges. And we can do like SA destruction SV with parallel copies, and then resolve parallel copies. We can group it like that, I guess. That seems reasonable enough. Anyways, now that I've done reading for 35 minutes, it's about time that I start writing some code. So I guess we get to finally look at the middle end again, which is nice. So we can do split critical. Yeah, and we're gonna need that in general. So I think we could just avoid calling that at like the optimizer time and just like call this at the end and call it a day. But it's still nice to have. These are not passes, so this is okay. Yeah. So how did I do this before? We can just steal that. Instead of inst combine, we have split critical. We can do that. Okay. Okay. This is daunting. Okay. Let's just do that instead. This is faster. How do I do this again? Just copy that. I can just format that real quick. This is split critical. Okay. So what do we do here? So we want, I guess we want to just like do this, and for each basic block in F, get basic blocks, and then we do something here, question mark. So I'm getting pinged somewhere. Okay. Sorry about that. Okay. Next. So this is per function. For each basic block. So we're at this point now. So we kind of just need to. Can I just copy this in temporarily? Or at least this part. Eee, yuck. Okay. Let's. Okay, that's ugly. Let's. Okay, this is super broken. Okay, we're not gonna do that. We're that was quite dumb. Okay, so then for auto red in basic block. Oh wait. Then we want get unique edges? Yeah. We want to do that. For each of these. Okay, so these are all basic blocks, right? Yeah, okay. So then, how do I do it in the other stuff here? Maybe in simple ICFG? Oh, that makes sense. Oh, yeah, we'll just do it like that in case. Yeah, so we can do that. Parallel copy. We don't care about that. If it has multiple outgoing edges, then we make a new block and we insert. This is the bit of logic we care about, at least. So each predecessor. Pred. So we want its. So we want its successors. Actually. It's a ref. So pred. I think we can just count unique edges, right? This is greater than 1. I guess. Can we like denest this in any way? let's try to denest this. So if it's less than 2, then we can continue. How well does that for other viewers? That's a question I ask myself as well. But yeah, I mean, thanks for stopping by, Holy Sauce. Okay, so how do we make a basic block here again? Because we've done the opposite before. We've deleted basic blocks. So we want. Do we just push back, I guess? Is that what we do? This could not possibly cause any issues, surely. Or we could just insert before, I guess, right? Yeah. Do we do an iterator? We could just push back, because we reorder anyway, right? So surely it's fine. So we wanna make empty basic, or make new basic block. Replace pred successor, or pred edge to occur with BB. And then you want to replace basic block edge to pred with actually let's describe it like that. Or actually, edge from pred, the new basic block. So that's what we need to do there. And then like parallel copy stuff we can do at a different place, presumably. I think what I'll do today is I'll finish implementing this, and then I will figure out how to scaffold that stuff in the backend, and then I think we will just call it a day. Yeah, I had a rough night of sleep, so I'm quite eepy. Okay, so the question goes again. How do I make a new basic block again? Or at least, where do we insert it? I guess we could just change this to an iterator. So we want f get basic blocks. And maybe we should just we should rewrite these to use like specific traversal orders instead. Or you could just insert at the end. It's a control flow graph, damn it. Yeah, I really don't care actually. Let's just make a new basic block. Auto basic block. Actually, yeah, let's just do that. New block equals, so we want to make unique with our basic block. Can we just do that? Oh, we can't do that. What's the constructor for that again? Well, that doesn't help me. Surely this helps me. There we go. That helps me. Wait, but where's the constructor? Wait. Am I just blind? Oh, I am just blind. Okay, all good. Okay. Yeah, so we can just do this. So we want okay. Oh, and then we have to like look through the fees as well, I think, right? Yeah, we can do that. So we need a body equals. Can this? Actually, can we just give this like? Let's make Terminator first. Let's go on MIR Terminator branch. And then what does this take? Again, this is here. Let's just take successor. So this will take basic block. Yeah, we need to do that, I think. That looks correct. And we can give it empty list and then move Terminator. Okay, that doesn't work. We could just pull this into a helper function and denest a little bit, or at least make it less ugly. Okay, so we have Terminator, and we want to, we'll just copy the type from whatever we had, where it was. Yeah, we can just do that. Is this the thing? Oh, we can just do that. Yeah. There we go. Okay, first try. Okay. I guess we can move. Okay. So we make those. So we make the new block. So I want to replace the predecessor edge to the basic block with the edge to the new block. I guess we could just insert this now, right? Yeah, surely that's fine. So then we want actually no. We should do that at the end because right now we have the putter. And that avoids a little bit of duplicity. Let's just insert it at the end real quick. So we want... You should probably... do that, so you have a ref. Yeah, okay. Oh, wait, but then there's like iterator concerns. Oh, that's really annoying. Okay, we're just gonna do iter. Just do that. Does this work? Oh no. Okay, so we need to we want to do that, I think. Yeah, that'll do. Yeah, okay. Or is it better to just... I guess it's the same amount of indirection anyway, so it doesn't particularly matter. I guess this does more indirection up front, which is presumably a little bit faster because we chase one less pointer each time. Okay. So we get predecessors. So can we just like... Is there a way to insert before? Oh wait, this simplifies that as well. That's nice. So we want... this iterator insert before. Insert. Oh wait, insert does before. Oh, that's nice. Yeah, okay. That solves every problem I have actually. So we want PB's insert. Yeah, we can just insert before, and life is good. So we can do basic block iter. Wait. Copy of, so position and then value. So position, stood, move, new block. There we go. Okay, cool. That is very nice. I'm quite happy with that. Okay. So now we need to replace the predecessor edge. Is there a utility for this in here? No. I guess not. Yeah, okay, we're gonna have to do it the annoying way. Unless there's a way I could... No. There's not a great way to deal with this. Okay, so we want this is messy. So we need to get the... No, we have the predecessor. We just need to figure out where the edge is. Actually, no, we don't need to do anything complex here, I think. So we have pred. So we have successors. So we add edge to... We add edge to new block. This is annoying because I have instances where multiple basic block edges point to the same block. So what is the best way to do this? I guess we could just loop through the edges. We have successors, yeah. So we have pred successors. Nice theme, thank you. Okay, so for auto, I guess out edge. So we want get edges, I guess. So this equals cur BB. This is what that is. So we want is get edges a ref? No. Okay, that's good. So then that's a copy. So we don't have any problems here. That means we can do we can remove edge to basic block. Then we can add edge to new block. And do that. Okay, and then we need to kind of just need to do the opposite here now. So we want for each in edge in, I guess, yeah, that makes sense. And then we want preds get edges again. Real quick, let's do this the lazy way. Let's name this out again, rename, and make that in edge. Okay, but instead of this now, preds. Okay, instead of removing edge to basic block, we remove edge to, we don't use BB anymore. We use pred, I guess? Yeah. Yeah, okay. Remove edge to pred. There we go. Okay, and then, yeah, so that makes sense. Now we just need to update the fees. So we want like, I mean, they're always at the top, so. switch I in. We can give instructions. We can just dynamic cast. We're doing this the really awful way still. I need to implement the fast dynamic cast still. That could be a fun side project. So we want this to instruction fee star. We want to do that. If not free, then we fee. We want to just break. Otherwise, we want so you want fee. Ah, that's annoying. So we want that. We want oh, that's so cursed. Okay, let's see what exists. Erase, that's what we're looking for. We want to erase the predecessor, so pred. Or we just want pred, yeah. Oh wait, no. We want to fee. We want to set predecessor of. It's just. Yeah, we can just do that. That should be by ref. Yeah, so we can do that. And then that allows us to simplify things a little. So then do that. Does edge modifying loops be stood replace? I'm not sure how encapsulated I have this actually. Yeah, it's a little bit awful actually. Yeah, this is like an abstraction on top of it. It's not like a direct access. It's stored as like edge and then count because I've made a mess out of here. So unfortunately, I don't think stood replace would work, yeah. Yeah, this is all just a fault of some really questionable design decisions earlier on in the process. I guess that's this entire project actually, now that I think about it. What's good, Ice Spiritual? It's good to see you. I'm really new to compilers and lowering, but I've always wondered why some compilers have multiple IR passes. It's mostly about like, there's two main reasons. The first one is like modularity. So if you have like a different source language, or if you have like a bunch of different source languages and a bunch of different assembly languages, and you want to make it modular, so you want to use like any combination of the two. It's useful to have like separate, separate IRs there. And I guess that also is extendable to just like the idea of using different combinations of passes as well. Like that's how you do opt levels, because sometimes you don't really care about it being you don't care about generating the fastest code, you just want something that compiles fast enough. The second reason is just like, from like a software engineering perspective, it helps separate separate concerns. So each pass, I guess, it manages a different. Each of them has like a different purpose, so it makes more sense to separate them rather than to throw them all into one mono pass. Okay, so we have 3 predecessors. This one is unique. Is there a way to just replace the key? Unordered map. Okay, sure. I know I have like a function for this already, but I've not built this out well enough. This is dumb. Why did I make this? Okay. There's so many bad choices here. Time for a refactor? Yeah. A lot of stuff is very overdue for a refactor, but there's just so much stuff. It's quite hard to manage, actually. So we want... Predecessor is new block. Get. Yeah, we can do that. We can just do that, I guess. Yeah, that looks about right. And then we insert the block and life is good. Okay, cool. Alright, let's see if this builds. Does it have any dependencies? I don't think it does. So that should be fine. Yeah, it definitely doesn't need those. Do we need to update any of this? I don't think we do. Oh, we need to update this. Because it's a new transform. Split critical. Let's alphabetize this. I'm not sure why this is ordered the way it is. There we go. Okay, so yeah, I need to rebuild that anyways. Why strings for pass name? Because I also reuse this for my like command line parsing stuff. And those are strings, so I would have to convert a string to, I would have to have like a if tree for strings somewhere, so I figured I might as well just put it here and call it a day. Yeah, it's all just like this whole code pile. I feel like when I first started working on this, I like tried really hard to keep it clean, and then it's just progressively degenerated since. Let's give it like if maybe. Let's just send this like temp1. And let's do. Actually no, -0. And then we add in split critical. Oh, I just overwrote it. That's stupid. Okay, let's do that. And let's do that. Give it temp2. Okay, well that doesn't help me. I guess I don't generate anything that causes problems here yet, right? Oh, I did. Okay, let's try that again. Dump MIR? There we go. Let's go Frog Imperium. How are you running Tmux in Windows? I'm using WSL. So I have WSL running Fedora here, and Tmux is in that. My laptop is running Linux, but I play Valorant, unfortunately. So I do need Windows around. Okay, so these are the same, which I guess makes sense. What the? Wait. What? What is happening here? It's temp 2. Is this correct? Oh yeah, I see. This makes sense. You know, C, and if you do between C and C++, would you learn first? I did learn C first. And if I would go back in time, I would learn C first again, because it helped motivate a lot of what exists in C++ for me, at least. And I also think like I would not have understood references and pointers properly if I hadn't just worked with raw C first. Hate bureaucracy. Yeah, that's how it be nowadays, at least. It sucks, but it is what it is. Yeah. Okay, so I guess there's not really a way to test this yet, because we don't really do all of the passes, we don't have all the passes that we need this for, but we can kind of just assume that this is correct, possibly. We'll just assume it is, and then when it breaks in the future, we will deal with it. Let's add source, middle end. What's good, Gurveer? Good to see you again. Okay. Implement split critical edge splitting. Not test. So I'll say hi, all the best, I'm leaving though. That's fair, yeah. Yeah, thanks for saying hi. Past deals with all the ABI stuff. That is all kind of encapsulated by the backend. So like, yeah. So we have this stuff for like instruction selection. And then we're also working on like, regalloc with like liveness analysis and all that shenanigans. All of this is towards that end, at least. Okay, what did we do here? Actually, wait. I just thought of how that might break some of this. Instead of if. Mem to reg, I think. Let's try this again. Will this do a diff? Okay, it won't. Unlucky. Is there a good test case here that I could use maybe? There's definitely one somewhere. Maybe it's in the book. Right, no, it was in the other slide deck that it was. I forgot what it was called. This oxygen is doomed. I like this, so I will keep that, but it was here? Was it this one? No, it wasn't. It was the other slide deck. Have you ever made a single pass compiler before? Technically yes. It was for our programming languages class, and that introduced compilers in like one lecture, and the rest of it was just about interpreters. So, I technically have, but it's like, it is like the most basic definition of a compiler. Let's try this again. It was this slide deck, I think. Let's go down. Sorry about that. It was here. We want to generate code that does that, I think. Yeah, let's... Is there a better example somewhere? I guess we could just do like an SSA test generically. Okay, let's call this like actually, maybe the other slide deck had other good examples. The compiler is a FreedomWare projected interpreter. That sounds familiar. Okay, sorry. Possible to interpret. Ooh, interesting. Okay, this is not what I was looking for. It was this. Has to say lost copy. Is there stuff here, maybe? Okay. Yeah, we can... I think we implicitly... Do we? You could look at the while test, actually, now that I think about it. Do that. Let's do while.c again. Okay. Well, crap. Okay, that does not help me. Okay, cool. What was I gonna commit again? This was... What did we do here? We reorder stuff in pass parser, add. Critical edge split. Okay, cool. I swear, I think this, yeah, so there's lost copy there. And then the swap problem. Yeah, okay. How do you even generate code that tests these at least? I guess we could try this one. I guess this one we can't really test yet, obviously. Can we make this work? Oh wait, we can definitely do something insane with this. Yeah, we can do that. We can test this out. Is this split? This is not split. Okay. Okay, let's just do that. Okay, let's make something here. So we have X and Y. We have like we assign those. So then while just do while true. We don't have true. We don't have true yet. Oh, okay. We will do something gross here. Just do that. Do that. Yeah, I really need to add for loops sooner than later. This is very irritating. Actually, we can just throw this in here. Let's see what this dumps out for. Yeah, let's see what this spits out here with SSA.c. Is this what we're looking for? I think so. Let's do. Okay, well that changed nothing. I guess that makes sense because it was already split. Okay, that's a really funny outcome actually. It's gonna be really funny when this pass actually did nothing and I can just not include it. Yeah, okay. can I make this work? Size T max? I used a negative number because I was lazy, and it turns out you can't use negative numbers on unsigned int for very obvious reasons. Yeah. So I need to fix that. That should just be entry. But yeah, it is what it is. Okay, let's memtreg. Wow, that did nothing. Okay. Well, that's fine, I guess. I guess I will preemptively write this. Actually, let's just int copy problem. Or cross copy problem. Okay. Is it WSL? Yes. I'm using WSL Fedora. Okay, so we have I. Do that, I guess. Y equals I. I guess we have int Y here. And do that. Let's try that again. That's not supposed to happen. Wait. Okay, that's really funny, actually. Okay, great. This was not what I was expecting to debug right now. I don't want to do this right now, actually. This is not what I want to spend my evening debugging. Memtoreg 214. Well, funnily enough, it generates code. Where did I mess up here? Oh, did I mess up the uses again? Ugh. Okay. Okay, I might just save this for next time. I do not particularly feel like staring at this. yeah, that's what we're gonna do. Yeah, we will stare at this more closely next time. But yeah, until that point, I'm gonna call it here. Thank you all so much for showing up today. If you're new here, make sure you like the stream and sub to the channel. It helps out a lot with the algorithm and gets my content out to more of you guys. While you're down there, make sure you join the Discord. It's a great place to hang out. Everyone's really chill. It's also the best place to get pinged when I go live because YouTube's notifs are quite terrible. Also down there are my GitHub and LinkedIn. Feel free to add me on those to stay up to date with what I'm doing. Yeah, I'm gonna go eat dinner because I haven't eaten dinner yet. Take care, y'all. Take it easy and have a wonderful rest of your day wherever you are.